Hello, ladies and gentlemen. Time for a little lesson on how to do the angles and chords assignment. To help us out, we're going to go back to the notes. So remember, we're working on some notes last time, just naming things like what's a tangent line, what's a secant line, what's a central angle, what's an inscribed angle. We're getting into like the actual theorems, the relationships between the different parts in these circles, and this first assignment uses them. And so our first one is when you have, well, there's two here. If you have a central angle, and then there's this arc that goes across, they have the same measurement. So whoa, sorry, I just jumped to the next page here. This central angle and this arc measure are the same number. They're both 80 degrees in this case, but if this was 40 degrees, this would also be 40 degrees. The M in front of the arc name just means measure of that arc, and we measure arcs by how far around the circle it's gone. So this has gone 80 of the 360 degrees around the circle. And then there's another relationship, and that involves the inscribed angle that covers the same arc here. The inscribed angle is always going to be 1/2 of the arc measure. And so if this was here instead 60, this would be 30 over here. If this was 42, this would be 21. And you can go vice versa. Sometimes you know the inscribed angle, you don't know the arc measure, and so you just times by 2. And so, work back and forth there. Another thing you need to be aware of is just another naming thing. When we're talking about arcs, when we name them, I would name this arc here the arc AB. We should use AB with the arc measure, the arc symbol on top. But sometimes you want to go the other way. And so there's names for those things. The shortest distance between 2 points is always called the minor arc. But going the other way around is called a major arc. And when you name a major arc, you do have to use 3 letters, because you have to, if we just do AB, that always means the shortest one. But if you want to go the other way, you have to say another point that you have to go through to go between A to B. So you have to do ADB there to name the major arc. Next thing to be aware of, these are actually just saying the same sorts of things. If you happen to know a arc measure, like this is 60 degrees, then you can get the other side just by taking 360 and subtract out the 60 and this far around is going to be 300 degrees. So you can kind of use logic to work your way through that. If you have a diameter that cuts through the center, then each side of this is going to be 180 degrees because, it's half a circle. But something that goes along with it is if you create a little inscribed angle across a diameter here, it makes a little triangle. And since this entire thing is a semicircle, over here is 180 degrees, then the inscribed angle is going to be 1/2 of that. This is going to be 90 degrees, which is why there's a little right angle there. So anytime you have a little triangle where the hypotenuse, where one side is a diameter, this angle here is going to be 90 degrees. And then we got some other postulates and things in here. You just have to realize you can add angles together. So if you know this arc measure, this arc measure, you can add them up, and that's the arc measure for all the way around there. And congruent arcs. If you have, you guys know what congruent means the same. Congruent arcs are the ones that have the same measures. So if they're both 80 degrees, then they're congruent to each other. And then we have another theorem. We're going to be kind of using all these things in little bits and pieces on the assignment. So we're gonna talk about some of the other ones. This one's different. If you have 2 chords, the angles inside here are equal to the average of these outer angles. So let me talk about it. So let's say this over here, this arc measure was, we'll call it 40 degrees. Notice that this intersection point is not at the center. If it was at the center, then this would also be 40. But since it's not, we don't know what one is. And let's say we have this other arc measure here. Let's say it's, let's call it 50 degrees. So if this one over here is 40 degrees and this one's 50 degrees, Angle 1 here is going to be the average of those two things. So you just have to add them up and then divide by 2. So the measure of angle 1 is going to be 40 plus 50, and then you divide by 2, which is going to be 45. And the same thing up here. If you know these two arc measures, you can add them together, divide by 2, and that gives you how big angle 2 is. I do want to mention that hopefully you haven't forgotten that vertical angles, which we have here, are guaranteed congruent 100% of the time. So if you know angle 1, this one's also the same. This is also going to be 45, given these numbers that are here. And then I think we're done with our theorems right now. Oh no, we're not. Just kidding. There's one more thing, and it's actually on a page that I forgot to copy over. But we can actually use this as an example. Let me do a little bit of deleting. On yours, you do have another example on it that lets you know how this works. So this next theorem is about how long these are. And so if instead of looking at the angles, we're looking at how long things are. Let's say this is 12 and this is 18. These, when the chords cross each other, they actually split each other in such a way that the lengths will multiply to be the same thing, which is kind of a weird thing. So let's just call this, we're going to just put some numbers here. We got X and Y, and we got, let's call it L and K. The theorem is that X times Y is going to equal L times K. And so if X was 12 and this guy was 18, and I know K over here is 14, I could find out this last piece by timesing this together and just kind of plugging into my little formula here. I would do 12 times 18, whoop, that's supposed to be an 8, equals L times 14, and then you can divide both sides by 14, and you get some number, and it's whatever that is. I need to get a calculator. Anyway, so there's a lot of different theorems, and we're just kind of practicing a bunch of them. Most of them are focused on the angles, and then there's some that deal with segments, which we'll get to on this last part. And so, at the beginning, it helps a lot if you read what's going on there and just kind of work your way through. There's a lot of, it's almost like solving little puzzle boxes. There's a lot of different things you can find, and just find the next thing and find the next thing and find the next thing to unravel all the pieces in your shape. So let's actually use practice B as an example of what's going on. Once again, reading this helps a lot. Realizing FH is a diameter and then JK is also a diameter is important because it splits it into 180 sides here, right? We got pairs of 180 semicircles. And then we got the measure of FHM, which is this one, is 40 degrees. It's already labeled. That's what this part is. And then we got the measure of arc HK is 60 degrees. So we got HK here. This is going to be 60 degrees. And then the measure of arc JL, which is over here, is 50 degrees. So that's already on there as well. Just this one wasn't. Okay. So now we're going through and we're just getting some measurements. So we need to get the measure of JF, which is right here. Well, if we knew this angle, we could use it. We could get it pretty easily. Or if we knew this measure, then we could also take 180 and subtract off that part that we know. And so there's a couple of different routes here. And so I'm going to start just filling in things I know. Oh, if this is 40 degrees down here, and this is an inscribed angle, then this whole part here is going to be 80 degrees. I wonder if that's something that's on here. FM, oh look, this one's asking for FM, so I know that one's 80 degrees. And man, if I had this part, that'd be useful. I don't have it though. Oh, but I can get it because I see here this is a diameter, which means this whole part is 180, and I know 60 and I know 80, so I can just use 180 minus those two pieces to get that. So I'm going to erase a little bit of symbols here. So this part is 180 minus 80 minus 60, which comes out to be 40. So this part's 40 degrees. That's from M to K. So it's asking for MK, and I know that's 40 degrees there. And so now that I know these two pieces, I got this section here, I can take that away from 180 to get this JF here. So it's going to be 180 minus 80, and then minus this 40 degree thing here, which means it's going to equal 60 degrees. So I got that part finally, 60 degrees. But along the way, I found out like some other things about it that also lets me know that this thing here is 60 degrees. So I can fill that in. I wonder if there's a JAF. It doesn't appear to be a thing we need to get. But yeah, so I'm just using these pieces that I know to help me get a piece that I don't know. And I'm just using these properties about inscribed angles are half as big as the arc measure. I'm using vertical angles. I'm using that semicircle is 180 degrees and just working my way through these different puzzles. So let's jump to a different one. Let's jump to this next part here, practice section C. We're going to use the theorem to help us get this this measure here. And the measure of angle X is going to equal the measure of KI plus the measure of LN divided by 2. It's the average of the two things, so I'm going to add these together and divide by 2. And so the measure of angle X is 31 plus 63, and divide it all by 2, which is going to equal, hold on, add them together, 94 divided by 2, so that's going to be 47. I think that's it. This is what I get for doing math in my head here. Yes, 94 divided by 2, 47. So that's what's going on there. Sometimes you're given two of the pieces, and they're different pieces. So in this case, we know the inside part. So I know I have 55 degrees, and it's the other two pieces added together and divide by 2. And I have to just do a little bit of solving. You know, you can times by 2, and then subtract off the 86, and you get your answer on that one. So sometimes you have to do a little bit of work. Let's get to this last section, because this is where we have to use the segment lengths theorem, which just says that if you times these together, it equals these two times together. So I'm going to do a little bit of work. 4 times 6 is going to equal x times x plus 5. Remember, if it's got multiple terms, we're going to put it in parentheses. And so we got 24 equals, I'm going to distribute this, x squared plus 5x. Hey, x squared, that makes this a quadratic. If only we knew methods for solving quadratics. I don't know, maybe equal 0 and then see if it's factorable. Don't forget factoring, it's kind of really important. And so here we are. We have a quadratic. We're going to solve it. Are there factors of negative 24 that equal 5? Let me think a little bit. Let's see. Negative 6 and 4. We got negative 8 and 3. Oh, look, 8 and 3. I just need to switch the signs there. So I need positive 8 and negative 3. So I got x plus 8 and then x minus 3 equals 0. So now I can finish solving. Send them both equal to 0 and solve. We got x equals negative 8 or positive 3. You should do a quick check of whether it's reasonable. This one is not, because you're not going to have a negative measure. And so you're looking at x equals 3. Let me make it look like an actual answer. X equals 3. Hooray, we did it. Sometimes you have to solve a quadratic. But that's what's going on. A lot of different theorems at work. You just have to get used to it and work through the practice, and eventually you'll get really good at it.